Welcome to Maths Hut. Today I am going to show you how to solve this problem, right? You see, this is the question and that's a algebraic expression. So we have to simplify this calculations, right? Right. Now, when you look this expression, you might see it's very complicated because it's too big and it has too much of components. But I propose you to simplify this first in your mind. So how do you simplify this in your mind? So when I see this one, I try to see this just like this. So I'm drawing here, I'm writing here how I'm going to simplify this in my mind. So look at this part, the top part, a power of 3, b power of 3 square root. So I write this one as simple a, right? This one simple a. And the bottom one, the 6a power of 3, I write simple b, right? So now you see this part I write as simple a, this part I write as simple b. And this doesn't change. Then I write this part, top part, as c. The bottom part, d, right? Then this doesn't change. The division is remained same. And AB, I write E. And this one, I write F. Okay. Right. Now you see the complicated expression I simplified into this, right? So how I solve this problem now, it's easy. You know, this kind of expression, the method is, if you have to multiply the algebraic fractions, the top part you just multiply a, c, bottom part also you multiply b times d. Right. Now what you do here, so if I want to divide this with this expression, you know the method is, I have to change this division into multiplication, right? So this I change, and after that I write reciprocal of this. The reciprocal of this means I swap the top and bottom. So then I write f goes up, e goes down, right? Then finally I can again multiply this, a, c, f, b, d, e. That's the final answer. So this is the one actually I'm going to simplify in my mind before I'm going to calculate this one, right? So this is the method I'm going to use. Now we're going to apply this method to the complicated expression, right? So now I delete this one. Okay. So now I write same thing again like what we did. So I write this one, a divided by 6 power of 3 and square root of this. So then I can multiply this. So when I multiply this, so I take this one, 3, a, b, and the bottom one, what I'm going to do, bottom one, you can see here, this whole set is squared. So I can remove this squared by multiplying by 2, right? So that means if I multiply by this 2 times 3, a 6, and 2 times 2, b 4, right? Then as I did before, I changed this to multiplying, and then I'm going to write reciprocal of this. That means the bottom goes up, divide by AB. Okay, right? So now what I'm going to do, I'm going to also teach you another important thing that you have to use here. That's, I think, not a big thing, you might know this. So for example, so if I write simple a power of 2, right? So multiply by again simple a power of 5. So how I do this one, then this is a base and that's a index. So I am going to add, multiply mean the theory is I have to add the index. So a 5 plus 2 is 7, right? So let's do this one now. A I divide by a 2. So if I had to divide, the rule is the index subtract. So here 5 minus 2. 5 minus 2 is 3. So we do like this to simplify this kind of expression. That's again the very basic concept. So I'll delete this one. Now I'm going to add that concept to here, right? So before I'm going to add that concept, there's one more thing. Now, if we have a squared number, let's say a squared. So if I multiply by this b squared, the expression is square root of ab, right? So that's another important theory. So let's say if I take the same number, simple a multiplied by simple a. So this goes like this. A times a is a squared and square root, right? So then we know always this and square root and square get cancelled. So when we have a both in one number, square root and square, we can cancel, and the answer is a. Okay, so that's again an important concept of square root and squares. So I'm going to delete this again. Right. Now after that, I'm going to write, look at here, this one and this one is same. So this is square root, this square root is same. So when I apply the theory I explained you, I can write this a b 2. So when we multiplying same number with the square root and square root, this get cancelled, square root get cancelled, and I just write this number, right? Then next thing I'm going to do, I'm going to see how many simple a's now here. So here is 3, right? 3, and here I just write again 3 a b k. So this get cancelled. Now this side I have 1 a b, right? Here bottom 6 a 3 a 6 b 4, right? Now here power of 3, and here 5, and the bottom 3 and 6, right? 3 and 6, and here 1. So we can take this. So we don't write it here, but we consider this as a 1. So now I am going to add this 3 plus 6 plus 1. 3 plus 6, 9. 9 plus 1 is 10. So then bottom is a power of 10. The 6 remain as here, no change. Then I take b, simple b. So here 2. So here 1. So we don't write, but we can consider 1 here. So then 2 plus 1 is, so I write on the top now, that one. So 2 plus 1 is b 3. So here 4 plus 1, B 5. 4 plus 1, 5. Right? Now here the 3 remain, no change. So now we have done that part. Now still we can do something. So here the top is 3, bottom is 6. So I can divide both the top and bottom by 3. So 3 times 3 is 1. 3 times 2 is 6. Right? Now the top one, A. So here 3 plus 5, 3 plus 5, 8. Now I can simplify further. So here I write 2 now, and the B power of 3, and it's 5 here. So then if I have to divide, I subtract. So then 5 minus 3 is B2. And here 10, here 8. Then I can again subtract. 10 minus 8 is again 2. And what is left is only 1 now, right? What is left is only 1. So this is the final answer of this question. So that's how we can do this kind of a algebraic expression, right? So see you again with another lesson next time.